In this video, we're going to talk about the characteristics of quadratic functions. We're going to look at parabolas and define a couple of the key features. You are going to take your notes in your booklet on page 2. So we're going to take some notes on our definitions here and then refer back to our equation. You'll notice that the graph I gave in two different ways. I gave it in standard form, which is this here, and then I gave it in what's called vertex form, which is the second one. First, I want to make the point that I used equal signs here. These two things are equal, and we're going to talk about graphing using both of these methods. For now, we don't care how we got it. What we're looking at is this graph here, this parabola, the smooth U. So a couple of things about parabolas. First of all, parabolas can either open up or open down. So notice this one opens down, whereas if I look at my parent function, it opens up. So parabolas can open up or they can open down. Some definitions. Zeros can also be called roots or x-intercepts. And this is where y equals 0. So if we look on our graph here, our zeros are pointing to our x-intercepts. Now I should be careful because x-intercepts are points whereas zeros are just the x-coordinates. So here my zeros are x equals 1 and x equals 3. That's the x-coordinates of the x-intercepts. The next definition, the axis of symmetry is the vertical line that divides the parabola into two equal halves. So in this case, it's this dashed line going straight through the center. Now, notice if I fold my parabola up along those lines, the two sides are going to match up. That's because it's symmetric. It's got that reflectional symmetry. So the axis of symmetry is that line. This is the same concept as when you drew lines through butterflies and stars and things like that to show the lines of symmetry. Exact same concept. In this case, since it's a vertical line, we're going to write an equation for that line. The equation of a vertical line is always x equals, and in this case the x value is 2. 1, 2. X equals 2 is the equation for our axis of symmetry. Our next definition is vertex. This is one of our most important things. So when we're graphing, the vertex is usually the first thing we're going to try and find. And it is the point where the axis of symmetry and the parabola meet. It is also the point where the parabola is at its maximum or minimum value. So if we look up here on this graph, our vertex here is the point 2, 1. And hopefully you can see that that is a maximum value. If you look back to your parent function on page 1, that's going to be a minimum value because it opens up. So it's going to be a minimum value. So that max or min depends on whether it opens up or down. And then our final definition, the y-intercept is where the graph crosses the y-axis. And this is where x equals 0. Now, that's the same definition as y-intercept for a linear equation. So there's no difference there. And on our graph, it's right there. So our y-intercept is 0, -3. So these are our key features for this particular graph. We will go back and look at our key features for the parent function, but these are the things we'll look for each and every time we are graphing a quadratic, each and every time we are graphing where we have an x squared.